Like everyone else, you're also shipping new features. But all of that new code that you're releasing is also new risk. Every function, every dependency, every microservice that you spin up is a potential failure point you have never actually tested under pressure. And when it comes to traditional feature flags, they tell who sees a feature. They do not tell you if that feature survives when things go wrong. Gremlin is trying to change that. They just launched failure flags, a no-code way to test how your applications actually behave under failure conditions without touching a single line of source code. And today we have with us once again Kolton Andrus, CEO and founder of Gremlin, to walk us through it. Kolton, it's great to have you back on the show. Let's start with the problem. When it comes to, of course, code, what gaps in reliability testing led Gremlin to look at this problem and build failure flags?
Yeah, so I think, traditional failure testing, everyone thinks about the infrastructure level. What happens when my VM or my host goes down, or there's some problem in Kubernetes or some problem at the network layer. But we see more and more people are building their applications in, serverless environments, in managed hosted environments, or the application developers are really separate from the team that owns the platform and the infrastructure. But it's those application failures that can be major issues in bringing down systems, or major bugs or failures that can end up causing, catastrophic outages. And so how do we enable those application developers to go do this testing on their own without having to wait on the infrastructure of the platform team, and to be able to quickly, while they're building code at an increased speed, answer these questions and mitigate these problems while they're pushing their code live?
Can you talk a bit about, if we want to go into the weeds, talk a bit about technical stuff, what exactly are failure flags and how do they work?
Yeah, so we have two variations of failure flags. We have an SDK version. So if you want to just include our library, it gives you a nice place that you can wrap a function or a call or a dependency in a failure flag, similar to a feature flag. It lets you enable who sees it, what users or what requests get those failures, and allows you to inject those failures. So what happens if that dependency fails or slows down? What happens if it throws a certain error code or a certain failure mode? You can replicate those. And then the other one, this no-code solution that we built, is a proxy that you can drop in front of your application, regardless of where your application lives, and inject that failure into the request on its way in or on its way out. And so that can happen both on the ingress side, when you're receiving it. What happens if there's a failure while we're getting to the serverless application? Or on the dependency side, when you're making an outbound call out to a dependency. So I'm calling a cloud service, and that cloud service, what happens if it goes down? Well, let's test that by injecting a failure, failing those requests, injecting an error code, and really understanding what happens to our system, our application, when that dependency that we rely upon fails.
Every time I was saying the word failure flag, my tongue was slipping, and I almost said feature flag, because that is, already well known, well adopted. How are failure flags different, and how do these two complement each other? Do they compete? They complement? How does that part work?
Yeah, when we built a feature similar to this quite a few years back, and part of the problem was the name. We called it application layer fault injection. And that was a mouthful, and the acronym wasn't that useful. And so part of what we did this time around is, let's make it easier for people to grok, to understand what we mean by this. And so failure flag is meant to imply feature flag, because people are familiar with feature flags. And the feature flag is a little different. Feature flags are meant to help you deploy or roll out code. They might live in your code base for a longer period of time, but their purpose is really gating what people see and enabling different code paths. Well, often those are still happy paths, and they're not really thinking about the failure path. And so similar concept, we're going to wrap a bit of code in a flag, but in this case, we're going to have the control to say, hey, turn this on and have this fail for everyone, for a subset of people, for a certain time period. And so it keeps those same concepts that chaos engineering brought to the table. Hey, let's scope it down. Let's have control over it. Let's make sure we're injecting the failure in a safe and thoughtful way. But it also allows us to be very precise about where we're testing those failures. And so again, it need not be at the host level or the container level. We can get down to an individual, function call, an individual network call to a dependency, so we understand how it fails. Circuit breakers, I think, are the best example of something you want to tune here. We know circuit breakers are a strong pattern. When we're calling a dependency, we want to be able to, open the release valve if that dependency is failing. We don't want to pound the dependency. We don't want to wait for that dependency if we think it's going to fail. And we want to build a fallback or some sort of graceful degradation if things are going wrong. And so how do we test those? Well, the best way to test it is to have something almost in line right there that we can control that failure. We can open it up. We can say, hey, this failure is occurring. We can tune that circuit breaker, and we can make sure that that fallback works correctly for the end user, that we get the right user experience further up the stack when that failure propagates back to the user experience level.
Now, I also want to talk about no code claim. How do you actually manage to run these experiments without touching single line of code?
Yeah. So I think that's where, while the network is the source of all our problems, the network can be the solution to a lot of our problems as well. And so by introducing this proxy layer, we can pass through all normal traffic as if nothing has occurred, but we can inject failure into the certain requests or request types or patterns that we're matching on the front side or the back side, as I mentioned. And again, so this is, hey, I don't have to go pull a library in to my application. Some teams, especially at big enterprise companies, there's a lot of security concerns about adding another dependency or pulling in additional libraries. That just increases friction. A team that wants to do this testing might have to now go through a months-long security review process to be able to consume this library, where a proxy that they can inspect and see all the code and is very simple at its root, they can put in place in the network path to be able to inject that failure. And again, this is where, if we need the infrastructure team or the cloud team or the Kubernetes team to be involved in order to go instrument and run those failure modes at the host or container level. In this place, once we have that proxy in place, which is a drop-in solution, we can go manage it through Gremlin's UI, and we can go scope it, turn it on, turn it off, and we get all the usual fail-safe and security features that Gremlin provides.
Can you talk about what kinds of failure scenarios can team actually simulate through this?
Yeah, so I think there's a wide variety. So, when we're talking about dependencies, what happens if that dependency is just unreachable? Hey, a cloud provider's having an outage. It's not that they respond cleanly. They often just do not respond. So we can introduce the connection doesn't connect on the other end. We can slow it down. So what happens if that service is under load? And if a service, a dependency you're talking to is under load, the way it's going to manifest back to you as the consumer is really just a delayed response, delayed processing time. And so by injecting latency into that connection, we're really simulating what happens if that service is underwater, failing to respond or responding very slowly. Because we can be, again, at the SDK level, we can be in the code, or at the proxy level, we can simulate what happens if certain error conditions hit. So what if we want to return a certain error code, a certain type of response body, a certain type of, explicit failure message? So that's where we can override whatever response is being returned, and we can respond, we can mock it in essence and return the exact failure mode that we're looking to replicate or to reproduce. And then lastly, really it's about that pattern matching. Hey, I want to match requests of a certain URL path, requests that have certain attributes to them, certain users, certain cloud regions, certain types of service parameters that we have with our environment. And so that's what allows us to be very precise about taking a specific example and reproducing it. When I worked at Netflix, we built something similar, and this ended up being a very powerful tool for us because it allowed us to inject failure specifically to our user accounts so that we were the only ones that saw that failure mode, and none of the rest of the population got impacted by it. And so there's a few examples where we saw an error in production. we had a theory about why this error was occurring. We were able to go in and inject this failure in a very precise way against our accounts, reproduce the failure, find and fix the bit of code that was wrong, and then hot fix it. And so in one instance, we took an incident that had occurred 20 minutes ago, pinpointed the cause, had a hot fix, pushed it out, and then we're able to test it on our own accounts before we pushed it live to everybody. So I think that kind of precision testing and that ability to get in and be very precise about reproducing a failure in a production environment, but for a limited scope of users, is a very powerful tool for engineers to have.
If I'm not wrong, there is also a built-in health check component. How does that work, and what role does that play here?
Yeah, one of the most important parts of running failure tests is knowing if it succeeded, if your system was resilient to that type of failure. And so one of the ways that we're able to accomplish that is by looking at the overall health of the service or the function that's under test. And often that looks in a very similar way. Do responses flow? Are we seeing errors coming from that function? Is latency and throughput remain stable? So by processing this code through a proxy, we actually have access to all of those telemetrics all that telemetry while we're running the experiment. And so while we're doing that, we can see that the application or the function remains stable and healthy throughout. Or if it's not, we can halt the experiment, clean it up, and let the engineer know, hey, you didn't pass this test. It didn't behave in the way you expected, or overall, your system wasn't as healthy as you wanted it to be. And that's just one of the ways that we can automate understanding how the system behaves so that engineers can focus on running the test and understanding, whether or not it passed, not needing to understand whether or not it passed or failed, and then focusing on if it didn't pass, how do they go fix it as quickly as possible?
And can you also talk about how do you measure, do you have any reliability score that actually measure whether, when it comes to failure flags? I just want to understand what do you measure? How do you also ensure the failure rate? Do you understand what I'm talking about? That, from A to B, what is the difference after using the failure flags, reliability of the code or the processes?
Yeah, so we built failure flags into the broader Gremlin platform, which has a reliability management component. And so we have within that reliability scores. We have test suites that are common failure modes that work out of the box to help people understand. We have ways to schedule those so they run on a regular basis. And so that really is what drives good hygiene around reliability. You can run these types of tests once in a while, but really your system is changing daily, hourly, by the minute in the most advanced systems. And so you need to be running these tests on a regular basis to make sure you're not drifting back into failure. And so the test suites give us a great mechanism for scheduling and running those tests. It gives new engineers or even senior engineers that are less familiar with the code a clear place to begin. And we roll that all up into a set of reliability scores that measure the overall reliability of that service on multiple dimensions. And that's really important when it comes to the leadership aspect of running a reliability program. There's many teams, there's many pieces of software. How do you know which pieces of software need more attention? How do you know which teams are doing a great job? How do you recognize and reward people when they're not having outages, as you want to incentivize the right behavior? And so that set of reliability scores really gives leadership an opportunity to see an overall view of the system and where risks lie within the system, but also to see where teams are doing a great job and where they're keeping on top of their failures to produce what we want, which is really boring systems. We really want systems that behave as expected, that don't fail and don't surprise people on a regular basis. And counterintuitively, it's a lot of work to have a boring system. You have to do all of the prep work and automation in advance to make sure things run smoothly whenever there's a traffic spike or a cloud failure or a new bug that gets introduced.
Can you share, if possible, a real world example? How would a team use failure flags alongside their existing feature flag workflow? How seamlessly it integrates, and how does that workflow look like?
Yeah, so you don't need to have feature flags to run failure flags. So I would say they're similar in concept, but they're not. There's no dependency or requirement between them. But if you were launching a new feature and you wanted to failure test it before it went live for the broader population base, you might turn on that feature flag for a percentage of your users. Well, before you do that, you're probably going to want to go in and test that failure mode to understand, do you gracefully degrade? And so an example might be, hey, I want to go test what happens when Amazon S3 has a failure. Well, I have a portion of my code that goes out and calls and fetches assets from that. What I want to do before I turn that feature flag on is I want to go run the failure flag to understand, hey, if Amazon isn't available at this time, do I have a fallback? Can I return something from cache? Can I gracefully degrade? Can I not show a component? Can I calculate or do the piece of work I'm trying to do another way? So that when you go and turn on the feature flag and start putting users on that new functionality, does it behave the way you want? Similarly, if you want to make sure that you are handling the load properly, you might go test the latency of that service first. Hey, I've got a new internal service. Maybe it's an identity service. Maybe it's a recommendation service. And I'm going to go see what happens if it becomes twice as slow or 4 times as slow. So I'm going to go run that experiment on some of my internal test users. And I'm going to understand, what does that behave like? Can we gracefully degrade? Can we alert? Do we know when that occurs? And that way, when we're turning on that new feature and we're dialing it up and putting traffic on it, we've already tested to see what happens if things start to degrade, so that we ensure that the customer experience remains consistent and of high quality throughout.
How mature is this tool? Is this pre-production tool, a production tool, or somewhere in the middle?
Yeah, well, we've worked hard to make it a production-worthy tool. I think, if you've probably heard my comments on this before, but if you're only testing in your dev or your staging environment, you're missing a whole class of failures that can occur only in production. Production has security groups. It has diversity of traffic. It has different load balancers. It has different traffic paths. And customers do different things than you expect. And you can't always anticipate everything a customer is going to do. And so we do an extreme amount of performance testing of our own failure testing on these types of products before we launch them. And we have for failure flags. We recently found an issue a couple of weeks back before we launched where we saw a performance degradation in an edge case. And it was all hands on deck for my team for the next week to go really understand and profile and fix every performance concern that we could find. Because the type of customers that we have are, Fortune 100 enterprise customers that are putting a large amount of production traffic through these through these failure flags. And so we need them to be performant when they're not injecting a failure. They need to basically be non-existent when things are running through the system in a normal capacity. And then when we are injecting the failure, we want to make sure we're only injecting that overhead that relates to the failure. We don't want to bring along any extra baggage as part of that. And of course, everything we build, one of our first principles is always about fail safes. And so if there's ever any failure in the control plane, if there's any user error or other failure somewhere along the way, then we want to fail in a way that allows the traffic to continue to work, where the failure doesn't get injected, so that we're not causing an outage, because we never want to be the source of an outage. We want to be the source of, very precise testing that teaches us about the system to prevent outages.
And how does getting started look like? Is there heavy setup involved? Is it something they can sign up themselves, self-serve, or your teams get involved with onboarding as well?
Yeah, so we have a trial within Gremlin, so people can go out and self-serve these capabilities on their own. Oftentimes, they'll consult with our team. Our technical sales team is quite adept. They've all been on call. They've all operated systems. And so they're there to help advise people on how to construct the right experiments, how to build the right tests, and how to interpret the results, which ends up being a big value add for a lot of our customers. But the beauty of the no-code solution is at its heart, you drop it in, you go into our UI, you select the failure, and you run it. And so there isn't a lot of setup. There isn't a lot of overhead that needs to be done. What works by default out of the box is very lightweight and easy to set up. But then there's a lot of depth that if you want to recreate something very specific or bespoke to your environment, you have that flexibility to go in and customize and configure it the way you want.
And if I may ask you, of course, you folks just launched it. Where do you think failure flag, reliability, SRE go from here?
Well, I think, as I've looked over the last 6 to 9 months, the problem of reliability does not seem to be going away. We seem to be having more and more failures. And my personal opinion is there's a lot of great work going on that's allowing us to increase velocity. 10x the number of code that's being written, 10x the number of deployments and our velocity overall. But with that comes 10x the opportunity for bugs, risks, failures to occur. And in these environments where things are changing often, I think there's more risk because of the unintended side effects and the knock-on effects that happen within distributed systems. So I think that engineers need more tooling to help them to be able to go answer these questions, and more of this tooling to fit into their automated pipelines, whether that's AI-based or traditional CI/CD. When you're moving quickly, you need safety nets. You need guardrails in place that help you to test these edge cases and test them in a quick and efficient manner so that you can have that be a feedback loop into your development cycle to make sure you're accounting for and anticipating these failure modes. So short answer is I think there's, more opportunity for engineers to be able to do this. And the key is there's many things happening and many things competing for attention. So as always, one of our other core design principles is make it easy to do the right thing. How do we make it simple and straightforward for people to go answer these questions so that they're able to move quickly in these modern environments, but do it in a way that mitigates risks and give them a safety net?
Kolton, this has been a fantastic conversation. This is a pain point most organizations face. So this is going to solve a lot of problems for them. And folks who are watching, please head over to gremlin.com to learn more about failure flags. And I look forward to many more such conversations ahead. Kolton, thank you. And I look forward to chat with you again. Thank you.
Always a pleasure. Thank you for your time.